NASA's Hubble Space Telescope confirms what researchers have long suspected since its discovery. Bernardinelli-Amber is the largest comet. Shortly after the discovery of Comet Bernardinelli-Bernstein C 2014 UN271 in the summer of 2021, one thing was already clear. The comet is huge. We may have discovered the largest comet ever seen. Gary Bernstein, who located the comet together with his colleague Pedro Bernardinelli, rejoiced at the time. Since then, the comet has been observed regularly. Now, a new study confirms what researchers had already suspected after the first sightings of the comet. We always suspected that this comet must be large because it is so bright at such a great distance. Now we can confirm that it is, says astronomer David Jewitt of the University of California, Los Angeles, UCLA. Jewitt is involved in a study of the Bernardinelli-Bernstein comet published in the astrophysical journal Letters. The comet is an incredible object, considering how active it is even though it is still so far from the Sun, points out the study's lead author, Manta Huai of the Mecco University of Science and Technology in Tampa. Bernardinelli-Amber is currently about 3 billion kilometers from Earth, moving through the solar system at a speed of about 35,000 kilometers per hour. We suspected that the comet might be quite large, but we needed the best data to confirm this. To obtain that data, the research team used NASA's Hubble Space Telescope. Giant comet Bernardinelli-Bernstein T 2014 UN271 is larger than any comet before. On January 8, 2022, the Space Telescope took 5 images of the comet, which is currently on its way toward the center of the solar system. The researchers' goal: to find out how big the comet's nucleus is an extremely difficult matter, since the celestial body is very far away. Even on Hubble images, it is very difficult to distinguish between the solid comet nucleus and the coma surrounding it, a diffuse and nebulous envelope that can spread over millions of kilometers. Huai's researchers eventually created computer models to distinguish the nucleus from the coma. The comet's nucleus is large and blacker than coal, Jewitt explained in a news release from his university. The researchers estimate that the comet's nucleus is between 119 and 137 kilometers in diameter. The previous record holder was Comet C 2002V Q94, whose nucleus was about 96 kilometers. Bernardinelli-Bernstein is thus more than 50 times larger than the cores of most known comets. The U.S. Space Agency NASA explained in a statement. According to the research team's calculations, Comet Bernardinelli-Bernstein also has a mass of 450 trillion tons, hundreds of thousands of times more than the mass of a typical comet that stays closer to the Sun. Comet Bernardinelli-Bernstein originates from the Oort cloud. Comet C 2014 UN271 originates from a region at the edge of the solar system called the Oort cloud. Common research opinion is that there are trillions of comets there. Oort's cloud is believed to be about 300 to 750 billion kilometers from the Sun. It originates from a theory of the Dutch astronomer Jan Oort from the year 1950. Because the comets in it are too far away and shine too weakly, the Oort cloud could not be observed until today. It is considered, however, as largest structure of the solar system. Comet Bernardinelli-Bernstein has been moving away from Oort's cloud for more than 1 million years, heading toward the Sun. Its elliptical orbit around the Sun will take it to its closest point to the Sun, known as perihelion, in January 2031. The comet will then still be about 1.6 billion kilometers from the Sun. Before then, it is unlikely to have come anywhere near the Sun, Comet discovers Bernardinelli. Bernstein and other researchers wrote in a study. In fact, this may be the most primordial comet ever observed, it says. A comet is a freezer from the time of the formation of the solar system. Comets are considered dirty snowballs because their cores are usually made of dust and rock that has frozen together. As a comet approaches the Sun, its environment becomes warmer and the ice sublimates. It goes from the solid state directly to the gaseous state. This is how the coma and tail of the comet are formed. In the region of space where C2014 UN271 is located, it is minus 211 degrees Celsius, a temperature at which carbon monoxide ice already sublimates. Researchers suspect that Comet Bernardinelli-Bernstein may have been active since as early as 2008. Because Oort cloud comets were not formed at the very edge of the solar system, but were in the midst of the action when the planets formed, they are considered valuable celestial bodies that can offer insight into that time. Research assumes that comets were flung to the outer edge of the solar system during the formation of the planets and moons, preserving elements from that time like a freezer. The giant comet Bernardinelli-Amber will be observed more extensively in the near future with the new knowledge of its size. For nearly 9 more years, the comet will come closer to Earth, then make its way back to Oort's cloud,